All right, let's start by splitting this over 0. Let's go limit as a approaches negative infinity. So that's going to be from a to 0 of, let's switch this. Let's go 1 over e to the x plus 1 over e to the x. And let's multiply everything by e to the x. So we have e to the x over e to the, let's write it like this, x squared. I could write it as e to the 2x also. So we're going to go plus 1. So we have e to the x over e to the x squared plus 1 dx. And then plus limit as, let's go b approaches infinity. And we'll go 0 to b of the same thing. E to the x over e to the x squared plus 1 dx. Now the antiderivative of this is the inverse tangent of e to the x. Because this piece right here, if you take the e to the x out, it's 1 over something squared plus 1. Well, that's the derivative of inverse tangent. We still have the limit as a approaches infinity, or negative infinity on this. And we're going to go from a to 0 plus limit as b approaches infinity of inverse tangent of e to the x. And that's going to be 0 to b. Let's go limit as a approaches negative infinity of inverse tangent of e to the 0 is 1 minus inverse tangent of negative infinity. Excuse me, e to, let's edit that. Minus inverse tangent of e to the a. Plus limit as b approaches infinity of inverse tangent of e to the b minus inverse tangent of 1. Well, now we have, well, inverse tangent of 1 is pi over 4. So pi over 4 minus, let's do this. Let's go inverse tangent of e to negative infinity plus inverse tangent of e to infinity, and then minus pi over 4. Well, this is 1 over e to infinity, and that's going to be 0. So inverse tangent of 0 is 0. So we just have pi over 4 plus. This is inverse tangent of infinity. And as x goes to, here's inverse tangent, as x goes to infinity, this is going to pi over 2. So plus pi over 2 and minus pi over 4. So I'm getting pi over 2. Here's the graph of the function that we're looking at. And we notice that the graph is, first of all, decreasing as we go to infinity and negative infinity. So in theory, we're adding on area infinitely, more and more and more and more. But the area is getting smaller and smaller and smaller and smaller. This graph decreases fast enough to the asymptote that no matter how much area we add on, the amount of area will never get over that answer that we got, pi over 2. It'll never get to pi over 2, but it certainly won't ever get over pi over 2.